Welcome back again. We are now venturing into acids and bases, one of the most critical section in this paper 2, stoichiometric calculations, relationships, the strength of both acids and bases, and your pH calculations playing a vital role in this one, and titrations. Don't forget those. So let's go through the recent question paper and see what we can learn out of this one. Question number 7 in a normal question paper. According to this one, they say, according to the balance equation below, a dilute solution of HCl is used in titration against an ammonium solution. Fine. HCl plus ammonia forms Na4HCl. So which is ammonium chloride. Then 7.1.1, they say define the term hydrolysis. We know hydrolysis is just a reaction of salt and water with water. Salt with water. Don't say dissolve. So just a reaction of salt with water or reaction of salt and water is fine. Now the next one will say calculate the value of 7.1.2. Will the final solution be acidic or basic? And now our analysis is that anyway, if we are reacting a strong acid, which is HCl, and a weak base, which is ammonia, therefore the product will always incline towards the acid, draws the strong part, therefore it will be slightly acidic. So we'll write acidic, fine. Then 7.1.3, yes, they say write down balanced chemical equation that explains the answer to question 7.1.2. In this case, let me just start because I don't know how far your level of understanding of hydrolysis is, because otherwise you can just look at the salt, ammonium chloride, and know between the two ions which one will undergo hydrolysis. But otherwise then we can easily ionize the salt first so that it make it easier. There's no mark for that. Ammonium chloride, when ionized, will be forming ammonium ion plus Cl minus. Now the rule of hydrolysis says only the ionic salts of weak acids or weak bases, that's the easiest one, undergoes hydrolysis, meaning that now this is come from the weak base, will undergo hydrolysis. This one's come from the strong acid, no hydrolysis. They say only ionic salts of weak acid or weak base. If you want to be more academic now, we'll have to say only the ions of only strong conjugates, ions here, only strong conjugate acids or bases undergo hydrolysis. Therefore, what is a strong conjugate acid or base? That will be a conjugate base that is formed from a weak acid. If it's a strong conjugate acid, is coming from the weak base. So therefore, the conjugate acid of a weak base is strong. The conjugate base of a weak acid is strong. The conjugate acid of a weak base is strong. That's what you should know. So if I've got ammonia, its conjugate acid will be strong. Fine. So in this case, then you take ammonium ion will undergo hydrolysis, because if you know, you will start from this one to say only ammonium ion will undergo hydrolysis, react with water to form hydro, because remember this one is a conjugate acid. If it's an acid, it has to donate the hydrogen to water, then water will form hydronium ion, and this one will remain with NH3. Therefore, according to Arrhenius, say any substance that can produce H3O plus is an acid. Therefore, ammonium chloride is acidic. So you don't have to say that one, but they wanted just only this. They will give you the 3 marks. 1 mark for the reactants, 1 mark for the products, 1 mark for balancing. That's how the 3 marks will be distributed. The next question, 7.2. Now, so we're starting with 7.2.1. For the above, titration, 25 cubic centimeter of 0.1. Most of the cases in this case underline the 2, please. To a volume concentration of ammonia, you see, they will give you number of moles of ammonia. Solution is titrated against 40 cubic centimeter of HCl. So there now we need either concentration or number of moles. Fine. Now, is HCl strong or weak acid? We know naturally HCl is a strong acid. Just say strong, in this case acid. Fine. If it's a strong acid, now 7.2.2. Now they say explain the answer to that one. Why is it a strong acid? Remember, lately we were told how to explain that one, because this one it ionizes completely in water or in solution to form high concentration of hydronium ions. If you do that, then you'll get the 2 marks. If you just write it half, they can give you even no mark in this case. So remember that. Fine. 7.2.3, they are telling us to say write down the name of the indicator that is most suitable for this reaction. Remember, if we react a strong acid and a weak base, then we need methyl. So in this case it will be methyl orange in this case. Fine, that's a suitable one. 7.2.4. now explain your choice. Why do you use that one? I've already done that in before we talked about that. So you just say titration of, because this one is a titration of, or reaction, not even titration. You just write reaction of strong acid